Hi, in this video we are going to talk about queue in STL. So a queue data structure works this way. You have a set of items, you put them in, first out order, right? So first say 10 is inserted, then 20 is inserted, then 30 is inserted, then say 40 is inserted. Now if you remove an item, this 10 will go out first, right? Because this was inserted first. This is different from stack. In stack, if I remove an item, 40 would go out. In queue, if I remove an item, the item which was inserted first has to go out. If I do remove an item now, 20 will go out, right? And if I insert one more item, it will come here. It is like a normal queue of people. The person who came first will be served first, right? That's the same idea. Let us take a look at this program. To use a queue, we need to include queue. Also, one more thing, if you want to use queue directly, you need to use namespace std. Otherwise, you will have to write std : queue. That is the same thing with vector, stack, or pair. We need to use using namespace std, or we need to put std here, std : Let's now take a look at this program. We have an empty queue, initially an empty queue, right? Nothing is there in the queue. Now we inserted 10. Now we inserted 20. So after insertion of 20, the queue becomes this: 10, 20. Now we inserted 30. So the queue becomes this: 10, 20, and 30. So this is our queue now. There are these functions, front and back. The front function gives you the front item of the queue, the item which is going to be removed first. So what will this front print? It will print 10. Because currently 10 is there at the front. What will back print? Back will print 30. So we'll get 10 and 30 as first output. Now we are calling pop. So pop function removes the front item, right? It follows the simple FIFO order. The person who came first in the queue has to be served first. So if you call pop, 10 will go out, right? And the queue will become 20 and 30. After that, if you print front and back, you will get 20 as front, 30 as back. So the output after calling the pop will be 20 and 30. When we begin queue data structure, when we begin understanding queue in STL, one thing might be confusing, because in academics, when we study queue data structure, we are taught operations as NQ, DQ, but STL calls them push and pop only, right? So this might be slightly confusing. Push works as an NQ that you study in your academics. Pop works as DQ that you study in your academics. Pop removes the first item that was inserted first, and push adds an item at the end of the queue. Let us now take a look at this program. Here we demonstrate how a queue is traversed. So we have an empty queue. Now we insert 3 items. Now we are traversing it. So to traverse the entire queue, we need to remove the items one by one, like stack, right? So what happens? Your queue contains 3 elements as we discussed earlier: 10, 20, 30. Now what we do, we run a loop. While queue does not become empty, we print front and back of the queue, and after that we remove an item from the front. So what will be the initial output, the first iteration of the loop? It will be 10, 30. Now we remove an item, so 10 will go away and you will get 20, 30. Now you remove one more item, so 20 will go away. You will get 30, 30. And after that, queue will become empty. 30 will go away. So when the queue becomes empty, you come out of the loop. So we have covered examples of all the functions here. Only size is left. So let me just quickly cover the size example also. Size returns the number of items in the queue. So we'll get 3 as an output because queue has 3 items. Let us now talk about time complexities of different operations and internal working of the queue. All these operations in queue have time complexity as big O of 1, like stack. Let's see how. How does queue work? Queue can be implemented on top of any underlying container that provides these functions: empty, size, front, back, because these functions have to be implemented here. Push back for the push, pop front for the pop. Please note the difference between stack and queue. In stack, we had this requirement that it had to be pop back, right? But in queue, we insert at one end and remove from the other end. That is why we have back in one and front in the other. Now, which containers provide these functionalities in big O of 1 time? There are two containers actually, list and dequeue. Vector is not there this time in the list. It was there in case of stack, but it is not there in case of queue, because vector does not provide pop front in big O of 1 time, right? So pop front is not there. Among these two, if you do not specify any container, by default, queue is implemented using dequeue container. So queue is again a container adapter. It's a container adapter like stack, because it just works as an interface on top of other container. In this video, we talked about queue in STL. We talked about some example programs. We talked about its operations and their time complexities.